your GDC can be used to graph composite functions, and that's what we're going to look at today. Graphing a composite function on your GDC, how to find the key features you need to sketch it, and then two different ways of evaluating a composite function. So, I've already gone ahead and graphed our functions f and g. F is f1 in the calculator, g is f2. So for this composite function, I'm going to enter f, which is f1, of g, which is f2, of x. Okay? So I go tab. Before I do anything, I want to uncheck these boxes because I don't want to see f1 and f2. Just f3, which is f1 of f2 of x. There it is. So, I'm now going to do the sketch of that graph. And so I want to start by finding axis intercepts, turning points, and asymptotes. Axis intercepts are the easy ones. Now let's start with zeros. If I go menu, analyze, 0, give it a lower bound and an upper bound to look at, then it will find that x-intercept for me. Alright, so I know that it's going to be there, but there is an alternative way of finding those intercepts. If we go menu, trace, graph trace, then it's going to come up with the y-intercept, which is the only way to find that y-intercept. So we can mark that in 0, -3/4. And then as we move along, it stops at key features. So there it gives us our first 0, 0.634. And then as we continue to go along, just have a look at that x value and what it's doing. And bigger, and then 1.8 it's on the left, 2.1 it's on the right. So our asymptote is probably around about 2, and we'll have a look at where to find that in a minute. So keep scrolling through, there's our next 0, 2.37. You could have found that using menu, analyze, 0, but 2.37 is there. Alright, now, we found those key features. The next thing we want to find is clearly there's a minimum turning point here. Now you can do that using graph trace. Okay, 3, -3. Or you can do it finding menu, analyze graph minimum, giving it a lower bound and an upper bound between which to look. Either way gives you the same thing. Graph trace I think is the easiest because it allows you to stop at all of those key features, and it allows you to investigate behavior of asymptotes. So we've got our minimum value, 3, -3. So we need asymptotes before we go any further. Now to investigate this asymptote, let's just have a look at what it's doing at a really large x number. So go menu, trace, graph trace, and just type in, say, 900. And have a look at that. It's getting lower and lower and lower, approaching -2. If we look at the other end before we mark anything in, let's go a really negative number and have a look. As we go down, it's getting closer and closer to -2. We can also investigate that using a table. Menu, table, split screen table. Okay. And we can investigate F3. Alright, straight away it's actually come up with x equals 2, functions undefined. That's giving us our vertical asymptote. Here, at x equals 2. Our horizontal asymptote, well, let's just follow the graph and we can see what it's approaching as x gets larger and larger and larger. It's getting closer and closer to -2. you can investigate the behavior at the other end. And we can see that it's getting closer and closer and closer to -2. So that is our asymptote. A graph is allowed to cross an asymptote. Alright, and we actually see that here. The behavior, let's get rid of that table, menu, table, remove table, and just bring it back to x equals 0. We can see that the graph does cross -2 here, but it's the behavior at the extremities. So asymptotes, horizontal at any rate, are referring to the behavior at those extremities. So what's going on here, left side's easier to sketch. It's got to be that. And that is what we see on the graph here. Here it's doing that. On the right of that vertical asymptote, down to there, and then it's going up. Done. Okay, we've got our intercepts, turning point, asymptotes. To evaluate that function at x equals 5, what we're going to do is put in a relation at x equals 5 and find that point of intersection. So we go menu, graph entry, edit, relation, type in x equals 5. Don't see it, so you can either drag around or go into window, adjust your window settings so that it's actually going to include x equals 5. The intersection of that blue line and black line will be the answer. So we go menu, analyze, intersect, click the corner, drag it out so that that point of intersection is included in the region. There's your point of intersection, -2 and 5/9. The other way to do that is using a calculator page. Add calculator, and you literally just type in f1 of f2 of 5. Done. Okay, so that's how you work with composite functions using your GDC.